Welcome to Pachira Talks. Today, we are going to talk about network security again. Yes, this is the fourth video in the network security. There will be many more coming. And today, we are going to understand a couple of really interesting topics, but all from the security perspective. So, what are those topics that we are going to cover today? As you can easily guess through the picture that I'm trying to prepare. So the very first is pairing. We will understand the pairing, then we'll understand the networking or security aspect of the pairing. Then we'll see how it is helpful, why we need it, and the things that we can do from security perspective. Same goes with the VPN gateway. We'll understand how VPN gateway helps us, how VPN gateway helps us from security point of view, and what exactly it is, things like that. Then we will understand gateway transit, which is again a part of virtual VPN gateway. But for the sake of topic, I just write it down here so that I will not forget. Okay. All right. And we'll see a couple of use cases, examples while talking about these topics. Because this is security specialist, so our focus will not be more towards operation. Our focus will not towards administration. Our focus is always about security, and of course from the architecture and design as well. Okay, so just to understand what is pairing, what we have done, we have just created this big box which is representing Azure. And in the Azure, we have two virtual networks, VNet 1 and VNet 2. Now, each VNet is private isolated network. We do understand that. Now, this VNet is 1.2.3.4. Let's suppose, don't just start laughing. Okay. And this one is like 2.3.4.5. The point is, CIDR range is different in both the VNets. Okay. And if we want this VNet to talk to this VNet, then what we do peering. We do peering. Okay, that's what we do. And what is peering? Peering simply means that's the reason I just created Azure here. It simply means this traffic. This traffic is not going outside the Azure, right? It's not going outside the Azure and getting into VNet 1. Similarly, this traffic is not going outside the Azure and talking to this. No, it's not doing this. So what it is doing, it is going directly here, and this is going directly here. How? Because it is using Azure backbone. Okay. So this is using MS backbone, Microsoft backbone. All right. So this is what the pairing is. I'll show you on the portal. That's not that important. More important is to understand the concept uh, specifically from the security aspect. All right. So we know we have covered these topics many times, but for this particular series, I wanted to talk about these things. So before we hit the security aspect, we should talk about what it is for the new audience, for the fresher audience, because it's been a while. So, what is network peering if we have to define? What is network peering? So, network peering is a process that connects two separate VNet, enabling resources in those VNets communicate directly over the Microsoft backbone network. Okay. Now, let's suppose there is another VNet here, and we call it VNet 3. Why I'm creating this? Because this peering this pairing is non-transitive relationship, meaning if VNet 1 is paired with VNet 2 and VNet 2 is paired with VNet 3. Okay. It doesn't mean VNet 3 can talk to VNet 1 directly. So this is connected, this is connected. So it doesn't mean if this VNet 1 is a friend of VNet 2 and VNet 2 is a friend of VNet 3, then VNet 3 will definitely a friend of VNet 1. No, 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 no. So it's not transitive. The traffic cannot go like this. It's non-transitive. Okay, very important. This is something which is usually asked in the interview and all. So non-transitive relationship. So I should write these important points here. Let's use this. MS backbone is already there. It's non-transitive. Okay, why I'm writing this? Because this will help us summarize at the end and eventually help us to cement the knowledge. So by pairing VNets, what we are doing, we are essentially merging them for connectivity purpose, allowing resources in each VNet to communicate with each other as they were in the same virtual network. Yes, that's very important. As they were in the same virtual network, which simply means high bandwidth and low latency. Usually you connect on-prem to Azure to different multi-cloud, whatever. There will be some kind of latency comes because of a lot of things, but it will act like a one single network. Act like a. It will not be a single network. It will act like a, and it will offer a high bandwidth and low latency. That is also one of the benefit we opt for peering rather doing or creating something else or some other way of connectivity. Okay, all right, fine. So, and this connectivity can be easily achieved. You need not to pay for the gateways, no need to deploy a gateway. We usually do when we connect with the on premises. So, no additional hardware, no public internet involved. So, it is secure and it will give you high bandwidth, low latency. So, it is a wonderful tool where we want to communicate between the virtual networks. All right, so we all understand this as of now, but if you are thinking why we need to communicate, why can't we create a big network at the very first and do not do all these kind of complicated, complex things? Well, there are multiple answers to this. Usually, when you create a network design or a landing zone in Azure for your on-premises workload or maybe for the greenfield, there is a way to create the design in a best possible way, following the guidelines, right? Where we have multiple virtual network for like one for the connectivity, maybe core, maybe hub or shared services, maybe independent VNets. So let's take few examples in which we need virtual net pairing. For example, you started with the single one. Let's suppose you were a small organization, but you will expand, right? You will expand. Right now you have, for example, 15-20 VMs. You're running one wonderful wonderful mission critical application which is in profit. Then you realize you can get something, some more applications created from one idea to another. You started creating another one, then another one. So you're expanding, your business is expanding, your organization is growing, so their network needs expand, right? So you want to create a separate network for a new idea. Then finally you realize, let's connect those things for any reason, right? So peering allows for the seamless connection of VNets across different regions, facilitating global expansion without the complexity of managing multiple different networks, right? So network expansion could be one of the reason right? Then there could be reason like companies often have resources spread across multiple VNets for organizational security or compliance reasons. So you could say resource consolidation is the reason. It could be anything like I told you, the designing guidelines or security or compliance. And peering simplifies the management of these resources by allowing them to communicate more efficiently. And finally, low latency, right? This this provides us low latency peering, so we always prefer peering over any other means of communication or creation of connectivity. All right, so as of now, I think peering is clear. Why we do it is clear. The benefits is clear. What about the security aspect? This isn't this the security specialist series that you were talking about? Well, definitely. So, all right, let's talk about the security aspect. Let me write it down here. Security aspects. All right. So, security aspects are, so the very first security aspect is isolation, or you can say boundary preservation. Isolation. This should be isolation and boundary preservation. Now, if you're listening me properly from the very first, I started talking about peering. I may point something that I pointed at that time. All right. So, when two virtual networks are paired, they establish a direct connectivity link that allows resources in one VNet to communicate with resources in another VNet. Despite this connectivity and this uh, virtual network 1 and 2 acting like one, right? I told you. So it's crucial to note that each VNet still retains its distinct set of policies, configurations, and most importantly, its isolation. They're acting like a single network, but they have their own isolation. All right, what exactly it means, if you are wondering, let me help you understand. This simply means VNets do not inherit policy or settings from one another. For example, you have NSGs, route tables, or firewall configuration applied to VNet 1 here. Uh, it will do not automatically apply to VNet 2. VNet 2 still have its own policies, its own NSG, own route table, and everything. This ensures that administrative boundary are maintained, and VNets can enforce their security policies independently, right? Independently. And so this is the security aspect, a wonderful security aspect. Isolation, still isolated but acting like one, and the boundary is preserved, right? So this isolation is fundamental for maintaining the security and compliance. For instance, if your organization has separate VNets for development and production environment, peering these networks does not compromise their operational or security boundaries. Administration can still enforce different security policies in each environment according to their specific requirements, right? All right, this seems really good. Now, what else? Well, another one is, well, we have talked about it when we were talking about peering, but yeah, let's make a point here. Private and secure communication. Let's make it secure communication. Okay, secure communication. Why? Because communication between peered VNets occurs entirely over the Microsoft backbone, right? Microsoft backbone network, which is inherently secure and isolated from public internet. Since this traffic is confined to the Azure infrastructure, it is not at all exposed to the external threats that typically affect internet facing communication. So this the isolation and private nature of Azure Backbone provides a secure pathway for data transmission between peered virtual network. Okay. So while the traffic is not automatically encrypted, remember this point, because in VPN gateway it will, but here it's not automatically encrypted. It travels over the private Azure backbone. So take a relax. I would not say chill. Okay. The privacy and isolation of this backbone network ensures that the data remains secure as it moves between the virtual networks. For most scenarios, though, this level of security is sufficient, especially considering the traffic does not traverse the public internet. Okay. So, if you're wondering, that's fine, but what if, this is the requirement of my organization? If traffic get out of this VNet, doesn't matter if it is going through the backbone or whatever, it should be encrypted, right? So what you can implement, you can implement the data in transit mechanism on the application or the data layer. First way of doing it. Second way of doing it is apply, do not go with the peering, just deploy a gateway here, and do the VNet to VNet connectivity, because gateway sends the encrypted traffic. Okay. The best idea is for the organization with specific security or compliance requirement, just go data in transit with Azure, within Azure, by encrypting the various mechanism to encrypt your application or data layer. Okay. All right. So I think we are good with the peering. This peering part is done. We talked a lot about peering, so we should conclude it. So the communication between Azure peered networks happens over Azure MS backbone. I have said this many times now, it would be in your subconscious mind, which is secure and isolated. We talked about it, offering a private pathway. Here to here, it's a private pathway for data that mitigates the risk associated with the public internet exposure. While the traffic is not automatically encrypted, the inherent security of the Azure backbone suffice for most use cases. Organization with specific needs for encryption due to regulatory or compliance requirements have the flexibility to implement additional encryption strategies as needed. We just talked about it. All right, so I think we are pretty much good. There is something else we can also add here. I think that will make it is kind of overlapping, but we can make a point. Controlled access. Okay. So, if what is that controlled access? Well, controlled access in the context of peering refers to the ability of administrators to precisely manage the restrict traffic between the peered VNets. Despite direct connectivity that peering provides, right, the boundary preservation, but still the administration can have the ability to restrict traffic between the peered network. What it simply means, through the use of NSGs and firewall rules, administrators can define granular access policies that govern the flow of traffic between peered uh, VNets. This includes specifying allowed or denied traffic based on the source and destination IP addresses. If you remember the five tuples we talked about, network security, one, NSGs, IP address ports protocols. So access control can be as broad or as specific as required. So controlled access, you get it in the peering as well, though it's acting like a single network. So what is the security benefit? The ability to enforce controlled access between peered VNets enhances security by ensuring that only authorized traffic is allowed to pass between VNet. This is crucial for preventing unauthorized access and limiting the potential attack surface. All right, I think now we have made all the points, all the security aspects here for us. Now quickly check the VPN gateway. Okay. All right, so VPN gateway in Azure is specific type of gateway, virtual network gateway. Okay, let me create one. Let's suppose this is our VPN gateway. This is our VPN gateway. All right, why it is yeah, a special type of gateway. I would not say special, maybe it's a slip of tongue. It is a type of network gateway designed to send encrypted traffic. Maybe that's why I was trying to say special, encrypted. But it's not special, that's its job. All right, encrypted traffic. between virtual network and on-premises location over the public internet. All right. So let's suppose we can create one more, or not on the Azure. We should not do it on the Azure. We can create somewhere else. Let's create here. Maybe this is on-prem. Okay, just for the understanding, the mind maps helps us get the concept clearly. So it serve as a bridge that securely connects your on-premises network to Azure, or can be used to connect two virtual network, as I said regarding the encrypted traffic. So what we'll do, we'll create this VPN gateway, put it here in the virtual network, and there would be a VPN tunnel here. Okay, there would be a VPN tunnel, and encrypted traffic will pass here. So this act as a bridge. This act as a bridge. Only then traffic get in and get out. So again, just for the sake of understanding, what is VPN gateway? Well, a VPN gateway facilitates the creation of a secure and encrypted connection known as VPN tunnel between two networks over the internet. It uses standard VPN protocols like IKEv2 or SSTP to ensure the CIA. Yes, it's not that CIA, but confidentiality, integrity, and availability of data as it traverses the insecure public internet. Why? Because here is something which is ruling the world: internet. Oh, okay. It goes via internet, but in a secure tunnel. All right. So if you thinking, all right, that's fine. I understand that, but why we need VPN gateway? One point is clear for the connectivity through a secure tunnel, but it could also be used for the secure remote access. Why? Because it enables secure access to Azure resources from remote locations as well. If you have somebody sitting here thinking, I would like to work from home today because of XYZ reason, so he can do that through his laptop sitting here, and it can directly connect to this VPN gateway through point to site. For that, you need VPN gateway too, and it is again, it will ensure that the data in transit is encrypted and protected from the eavesdropping. All right, so that's all good. We understood VPN gateway, and at the back end, if you, because we create only gateway, at the back end there are a couple of VMs spin by the Microsoft, and they're like more than one VM for the high availability of the VPN, and we there are whole lot things we already covered in administration. So let's not go there. We'll focus on the security, because I have seen so many courses where they just talk about same thing, even if they are doing AZ 104 administration, they're talking the same thing. If they are doing 305, they are talking the same thing. They are creating the security, they are talking the same thing. They are creating AZ 700, they're talking the same thing. No, that's not the way. Administration will focus on the administration. This is the security series, this is the security playlist. So administration is done, or we'll talk some other day. Here we'll only talk about the security aspects. Just to get to the security aspect, we need to understand what this resource is all about, right? So that's our focus. All right. Sometimes I get funny. Already, data encryption VPN gateways. So this is the one security aspect. Let me write those security aspect down. Security aspect that we are more concerned about. The very first is data encryption. All right, VPN gateway. So data encryption within VPN gateway ensures that all information transmitted between network and the remote network remains confidential and protected from eavesdroppers. Eavesdroppers. Imagine sending a letter through mail, but instead of writing in plain text, you use a secret code that only you and the recipient understand. Even if someone intercepts the letter, they can't decipher it. Okay. So how it works? VPN gateway use strong encryption protocols such as AES-256 bit encryption, or there's so many others listed on the MS documentation. So to encode the data before it's sent over the internet, the data only can only be decrypted by the receiving end. Okay, it will encrypt here, send it here, and this will decrypt. All right, which possess the decryption key. If you remember, when we create VPN gateway, we share the key. So this process ensures that the sensitive information such as passwords, financial data, and personal information is securely transmitted. Then the second thing is isolation. It also helps in network isolation in VPN gateways. How? Well, network isolation refers here to the segregation of network traffic to ensure that sensitive information in critical systems are kept separate from other network traffic. This is similar to using dedicated roads for transporting valuable goods away from regular traffic, minimizing risk of accidents or theft. If I'm taking you away from the concept, if that's what you think, so stay with me. I'll make it very simple. We just talked about it. By setting up a VPN gateway, we essentially create a private tunnel through the public internet, as we showed here. All right. That isolates your data from the other internet traffic. This tunnel can be used exclusively by authorized users and devices, ensuring that the data and communication within it are shielded from unauthorized access and visibility. All right, so network isolation. Then we have again controlled access. Why I'm saying again? Because this is something also given by peering, provided by peering. These are the security aspects, okay? Don't forget it. Why controlled access? Because through VPN gateways, about it's like only authorized entities can access the network and the data transmitted over it. Think of it as having a secure key based entry system to a building where only those with the right key can enter. You didn't get it? Okay, let me explain again. VPN gateway incorporate mechanisms like MFA through Azure AD, access control list, and more to verify the identity of user and devices attempting to establish a VPN connection. This ensures that only those with the proper permissions can access the network resources, providing an additional layer of security. Just to make a point here so that you guys can understand properly, let's take an example of an organization. Let's say it's a healthcare provider which enables a VPN gateway for its remote staff to access patient records over internet, or outside the hospital's network. Then the VPN gateway is configured to require not only username and password but also a one-time passcode sent to the staff member's phone, ensuring that only authorized personnel can access sensitive patient information. All right, it's really good. Data encryption, network isolation, control access, but it can also help you in, which is again overlapping, I think, but we should write it down: authentication and integration. Authentication and integration. Both are security aspects. Okay. How authentication? Because authentication in the context of VPN gateways serve as the process of verifying the identity of the devices attempting to establish a VPN connection. All right. So just take a funny example. It's like a bouncer checking IDs before letting anyone into a club. Before any data is exchanged over a VPN tunnel, both ends of the connection must prove their identity to each other. This ensures that only authorized users or systems can establish a connection, preventing unauthorized access, which is the main agenda, right? So, how VPN works here exactly? Well, VPN gateway typically uses what? Certificates or pre-shared keys for authentication. When using certificates, each side presents a certificate that the other side verifies against a trusted certificate authority, CA. This process ensures that both the client and the gateway are who they claim to be. Okay. Very nice. So authentication is fine, which is more or less like control access, but both has a different, you know, goals. but overlapping, it's fine. And then the integration. Not the integration. Are you kidding me? It's not integration, it's integrity. You are maintaining integrity and you are integrating there. No, no, both are different things. My bad. I apologize. All right. So integrity. Integrity ensures that the data sent over the VPN tunnel has not been tampered or altered during transit. It's identical to sealing a letter in an envelope with a unique seal. If the seal is broken or altered upon arrival, you will know the contents might have been compromised. Integrity checks are crucial for protecting the data from being modified or malicious actors. And how it works in the VPN gateway? VPN gateway implement integrity checks using hashing algorithms. When data is sent, the sender generates a hash, a digital fingerprint of the message, and sends both the messages and the hash over VPN. Upon receiving the data, the receiver generates a hash of the received message and compares it to the hash that was sent. If they match, the data is deemed intact. If not, it indicates that data was altered in transit. All right. So that point is made, done, and dusted. All right, so let's conclude this VPN gateway as well, just like we did peering. So VPN gateway in Azure plays a crucial role in ensuring secure communication between different networks over internet. By providing data encryption, strong authentication, and network isolation, VPN gateway addresses key security concerns associated with the transmitting data over public networks. Whether it's facilitating remote access, enabling hybrid cloud architectures, or connecting distributed application, VPN gateway offer a robust solution for secure network connectivity in Azure. Right. So these are the security aspect of VPN gateway. We are done with the peering. So I am so happy to check this box. Now, finally, gateway transit. What about gateway transit? It's not that big, but yeah, we need to understand. Gateway transit in Azure is a networking feature that enhances the integration and the management of network traffic between Azure virtual networks and on-premises network. All right, let's suppose this is the VPN gateway, this is connected, and this is peered. Wow, this is all I wanted. So this feature becomes particularly useful as organization expand their Azure footprint across multiple regions. So this is our Azure footprint. We expand to the multiple region. This is our VNet 2. All right. So let's break down this concept. Gateway transit allows VNet that are connected through virtual network peering to share a common gateway. Now this and this are peered and this is the gateway and this gateway used to connect on premises. Now what we are trying to do, we are trying to use this gateway so that traffic coming from on premises to this network can be can be forwarded to this VNet, or when this VNet wants to talk to someone, it could use the remote gateway. For this VNet 2, this is a remote gateway, right? And this setup reduces the need to provision and manage separate gateways for each VNet. Simply, and what it will do, it will simplify the network architecture and of course reduce the cost and the management. So this is what the gateway transited. By default, peering was non-transitive, right? Pick it up. Non-transitive, transitive. But this is a transit gateway, means it will allow the transit, right? It will bounce here. Transit. All right. We good. We understood the concept now. What is the security aspect? That's the main point. Well, it's the very important security aspect is centralized security management. Right? Nothing beats this one. That's what the Microsoft doing all the time. They're just creating centralized for every resource, everything. Why? Because this is something which is very important. By using a shared gateway, you centralize the point of entry and exit for network traffic. There is only one bouncer needed at one gate. All right, this centralization makes it easier to enforce security policies, conduct monitoring, and deploy security appliances like firewalls or intrusion detection system in a consistent manner. First point. Second, if there is only one entry, that means it will reduce the complexity. There is no many resources, multiple resources that you need to manage, and it will enhance the control then, right? Nothing big. So eliminating the need for multiple gateways simplifies the network topology. Just get this point. Reducing potential points of failures. There are less point, less point of failures, and security vulnerabilities. There's less resources, less security vulnerabilities. There is only one resource, and you can manage it properly. You have all the eyes, mind, hands focused on one gate. So of course you'll be more secure, right, and less vulnerable. So with fewer components to manage, there is a less room for error, enhancing overall network security, right? Simplicity is the best. And finally, encrypted connectivity. While gateway transit itself focuses on routing traffic through shared gateway, the underlying VPN or express route connection ensures the data in transit is encrypted, maintaining the confidentiality and integrity of sensitive information as it moves between Azure and on-premises network. And that's the whole point of cybersecurity, CIA, confidentiality, integrity, and availability when you need it. Very well. So this was really, really interesting. All right. So there are nothing else left. We understood all 3 points and the security aspects of all the 3 points. We could do a little because if you see from the broader perspective, VNet 1, VNet 2 getting connected through peering, on-prem or Azure getting connected through VPN gateway. So we can compare this connectivity a little bit just to grasp the concept. Okay. All right, because you will need all these information while you're designing and architecting and talking to your customer. So, very first point, let's take a point of uh, pricing. You understand that, right? Peering allows ingress and egress. There is some charge, very little, but in both ingress and egress. But in VPN gateway, it is always egress that charges plus the price of VPN gateway. You have to deploy the resource, price of the resource. And if we talk about limits, peering allows up to 500 connections per VNet and VPN gateway as per the SKU that you select. Okay. So pricing and limit we talked about. Then there is an encryption. So VPN gateway sends the encrypted data, peering does not, but it doesn't because we already talked about it, right? So peering connection benefits from software level encryption as recommended or as per the need with no inherent bandwidth limitation though. So it's band if we talk about bandwidth, there is no limitation of bandwidth in peering and VPN gateway uh, bandwidth varies as per the SKU, right? And this peering is always if you compare the latency is low latency. All right. Another point is privacy and transitivity. Okay, because traffic through peering is always private, leveraging MS backbone without touching the public internet. VPN gateway involve public IP but can route traffic privately through MS network if global networking is enabled. Peering is non-transitive without additional configuration, whereas VPN gateway can support transitive networking if BGP is enabled. Right. Another point is time. Peering takes very less time, and VPN gateway takes a lot of time. It was not that interesting, but yeah, just we should also smile and laugh while learning something new, right? Make it fun. All right, so let's conclude this. I think we are done. It's been a while. We are learning too much. So, Gateway Transit in Azure streamlines network management and enhances security as organizations scale by providing centralized control over network traffic and reducing the complexity of network configuration. It supports secure, efficient growth of Azure based workloads, whether integrating with on prem data centers or expanding Azure services globally. Gateway Transit offers a robust solution for managing connectivity and security across diverse network landscape. Already, I think enough for today. It was interesting topic. I liked it, and we covered all the security aspects. just to make a point here, because otherwise it will not be that fun. This is the Azure portal, and let's go to the virtual networks. I'll show you. I will not go into the administration or operation stuff. Just wanted to show you. If you go to the network, there is an option of peering. Once you hit the peering, you need to add the peering. You have to give the link name. For example, we, as per the diagram that we created, mind map v1 to v2, and another one is v2 to v1. We just gave the name to the link, and here is the information of your remote gateway that I was talking about. Okay, gateway route traffic, forward traffic. From these settings, you can do what you can do. You can allow remote gateway or forward the traffic. Use the remote gateway or forward the traffic. Both the settings are here. Allow gateway traffic forward the peered virtual network, or enable VNet 2 to use the peered virtual network's remote gateway. Clear? Nothing much is there. If you click on add, it will just create the peering. Select the VNet 2. Uh, because of the overlap of the IP address. So wow, another point. The for VNet peering, you should not overlap. I think I made this point at the very beginning, but it's fine. That's how it happens. Very simple. That's the reason it doesn't take much time. It is happening at the backbone, but retaining their identities. All right, then, enough of talking. Let's close the video. Well, thank you for watching. I hope it was informative and you learned something new today. Well, thank you for watching, and you guys have wonderful day.